So this is going to be lecture 3, part 4 on chemical equilibrium and how to calculate equilibrium concentrations. The easier type of question is when you're already given concentrations at equilibrium. So if you read the problem, it says a gaseous mixture contains 0.30 moles of CO, 0.1 mole of H2, and 0.20 moles of H2O. If you look at it, it says that the unknown amounts, there is an unknown amount of CH4 in each liter, and that this mixture is at equilibrium. So these amounts are already at equilibrium. So if that is the case, remember Kc is all the concentrations at equilibrium. We do products divided by reactants. We plug everything in. Really, we're solving for CH4. It's fairly easy to do that. Basically, we're just going to multiply this side by 0.30, and we're going to multiply it by 0.1 to the third, and we're going to multiply this side by the same thing, 0.30 times 0.10 to the third. That cancels out the denominator, and then, of course, we're going to get, let's see here, 0.3 times 0.1 to the third, and then we're going to multiply it by 3.92. That comes out to 0.001176 is equal to CH4 and 0.020. Okay, dividing both sides by 0.020. Okay, and we will get that CH4 is equal to 0.059. This is the easier way to do it because the problem already gives you everything at equilibrium. Okay, the harder part is when things are not at equilibrium. They give you initial molarity amounts. So if you look at this problem, they say you have a mole of the carbon monoxide and water. Okay, you have 1 mole each. Okay, and it is in a 50-liter flask. So really, you have 1 mole. Okay, divided by 50 liters. This is 0.020 molarity of the carbon monoxide and the water. So really what we're going to do is we're going to set up our ice, our CO2, our H2O, and our CO2 plus H2 gas. Okay, and so initially we do have 0.02 of the 0.02 of the CO2 and H2O, and you have no carbon dioxide or water or H2 because it's the products. You're going to go minus x because these are the reactants, and plus x because these are the products. So therefore, at equilibrium, you have 0.02 minus x. Okay, you have 0.02 minus x, and x, and x. These are your concentrations at equilibrium. If you knew what x is, life would be good. So let's see how you're going to solve for x. You know that Kc is products over reactants, so it really is the concentration of CO2 times the concentration of H2 over the concentration of CO times the concentration of H2O. Okay, I just realized I wrote CO2, it should be CO. Okay, the original equation gives us CO. Okay, so we're going to plug in our Kc, or Kc given to us in the problem is 0.58. Okay, is equal to, and we have x times x. Okay, these are the products. And then we have 0.02 minus x and 0.02 minus x. Okay, nice part about this is that you have 0.58 equals x, and then this is squared, and you have 0.02 minus x, that is also squared. Okay, very important to note, if you see this on the homework, if you see a squared here and a squared here, and this squared is because this is the same thing, okay, then what you can do is you can square root both sides, okay, and that will get rid of the 2 there, the 2, this thing and this thing, the squared exponent, okay. So you have 0.58, the square root, okay, square root of 0.58. Calculator's freaking out a little bit. Okay, that comes out to 0.76 is equal to x over 0.02 minus x. To simplify this, I need to multiply both sides by 0.02 minus x. And I'm going to multiply this side by 0.02 minus x. Okay, so that cancels out the denominator there. So I'm going to bring it down here. We're going to get x equals, okay, and on this side we're going to have to distribute the 0.76 into the parentheses. Okay, so 0.76 times 0.02 is 0.0152 minus 0.76x. Okay, and so we're going to, I'm going to move the screen a little bit here. We're going to add 0.76 to this side and add 0.76x to this side. That gets rid of that. So 1x plus 0.76x is 1.76x is equal to 0.0152. I'm going to divide this side by 1.76. I'm going to divide this side by 1.76. That cancels out the 1.76. I have x equals, and that comes out to 0.0086. Okay, that's what x is equal to. Okay, but really they didn't ask for s. They ask you what is the molar concentration of each amount. So we got to go back to our ICE table and plug in x. So we're going to plug in 0.0086 into each of these numbers here. Okay, so therefore, if you do 0.02 minus the 0.0086, you're going to get 0.01136. So I'm just going to round it to that's okay, I'll leave it like that. Molarity of the CO, and also 0.01136 molarity of the H2O. And we have 0.0086 molarity of the CO2, as well as the H2, okay, because they're both X. Okay, so really, the book actually asks you for moles instead of molarity. So to convert back to moles, you need to multiply by your 50 liters across the board. So this actually comes out to, let me just do the math real quick. Okay, this actually comes out to, where did it go? 0.43 moles of CO, 0.43 moles of H2, sorry about that, I made a mistake. If you multiply each of these by 50, it would actually get you 0.57 of the CO, and then 0.43 of the CO2, and 0.43 moles of the H2. Okay, so this is the first kind of example in how to calculate amounts at equilibrium. I'm going to stop the video here and do the next two problems in the next video. This kind of problem is very specific, where you have the squared here and here, so you can do the square root on both sides. So why don't you go ahead and do those problems in your homework and then go on into the next video. The next video is going to be on quadratic equations. It's a little bit more complex.